Hello, my dear student. I'm Saktwala from Educatiz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of the rotation of rigid boards for our subtopic of the radius of gyration of a rotating rigid board. This is the new subtopic for our topic here. So how can we define the meaning of the radius of gyration? This is what we are going to try to see for our today discussion here. But before we proceed with our discussion, we are supposed to remember where we ended on the last session. So on the last session, my dear student, we tried to see the final application, the final point that explain how the perpendicular axis is applicable. And we said that always this is applicable for identifying the moment of inertia about an axis. It means along their diameter. This is what we tried to see on the last discussion. And we say that, my dear student, always along the diameter, the moment of inertia must be equals to 1 divided by 4 times the mr square, where m represent the mass of the disk, and also r represent the distance of the disk. And also we tried to see some examples related with that we looked. So now today we are going to see about the radius of gyration of a rigid of a rotating rigid boards. Now we could have the rigid boards. It means and that rigid board trying to rotate on an axis. Now how can we demonstrate the radius of gyration? That is what we are going to see for our today discussion. So as we observe here, let us try to look at the concept to consider some figures in order to identify the definition of the radius of gyrations. So consider a disk, a solid disk of radius r and a total mass m, which is uniformly distributed across the area of the disk as it is shown here. Now imagine we have the solid disk, my dear students, and that's the solid disk containing the mass which should contain the mass which is indicated by capital letter M, and also having the radius which is represented by the small letter which is r, as we try to see here. So this disk is distributed by the area. It means it must contain the area. That disk must contain the area as it is shown with on our figure number 4.14 Roman A. So the moment of inertia I for the disk about an axis through its center O is given by this one. That if we have the axis of rotation and that axis of rotation passing through the center O, and that disk trying to rotate. Now we should identify the moment of inertia by taking a half times the mr square. This we tried to prove on the past lectures. So my dear student, as we try to see here that suppose the mass of mass m of the disk is shifted to the concentrated at a distance k from the axis of rotation. Now imagine that from our figure number 17 Roman A, we try to take that mass, the mass of the disk, and shift their position. It means that to omit from the original position and put into another position, and they also indicate their distance. Distance yake pale baada ya kuihamisha imetengeneza distance ambayo ni sawa na k, kama tunavyoiona from the axis of rotation. So the resulting word disk has the same moment of inertia. So the resulting here thin word must have the same moment of inertia as that of the solid disk. Now the radius k at which the moment of inertia of the solid disk is the same with that of the thin word disk. Kwa ile moment of inertia sasa ya ile solid disk itaweza kufanana na ile moment of inertia ya ile Syneward disk. So this is called the radius of gyration of the disk. That is the radius of gyration. So by after reading this concept here, we could demonstrate the concept about the radius of gyration. As we know that after reading this statement, there are so something we have been again that if we take the mass of the disk and shift from the original one now and prepare the distance from the axis of rotation, that give us the radius of gyration. Kwa radius of gyration kwa definition yake tutasema kwamba this is the distance from the axis of rotation to the point where the moment of inertia remain unchangeable. That is the definition of the radius of gyration, kwamba kutoka kwenye ile axis of rotation kwenda kwenye point yoyote ile, it means tunatengeneza radius of gyration, tunasiita hivyo. Kwa that is the meaning of the radius of gyration. As we try to observe our figure here, that is trying to represent the solid disk and also the Syneward disk. This is trying to give us the concept of the radius of gyration. As we see initially, my dear student, we have our disk, and this disk having the diameter, having the axis of rotation, which it is passing through the center, or as we try to see. But we have the distance from the center here up to the any point of the circumference or any point of the disk. This is R. Now we have been told that if we take this mass, I know that the mass was placed at this or was located at this point. If we take this mass and shift their position, it could form the radius of gyration, because radius of gyration occur between the axis of the axis of rotation and also to any point where the mass will be located, and also the moment of inertia remain unchangeable. So Roman A, as we try to see here, this represents a solid disk, a solid disk. But let us focus for the second figure, which is the figure that represents the Syneward disk. As we try to see that we have the disk, and this disk is covered by the elemental disk. As we see here, it is covered by them some elements here. So as we observe that even for the second figure here, we have the axis of rotation, which is equal to x. As we try to see this line that is passing through the center, representing the axis of rotation. But from the center to this point, this give us the distance k. Na hiyo distance k ndo tunaita ni radius of gyration. This could be the radius of gyration. So the distance from the center or from the axis of rotation to any point where the mass is located and the moment of inertia remain unchangeable, this distance is called the radius of gyration. Kwa radius of gyration ya rotating of a rigged body must be represented by the symbol K, as we observe here. So in general, we could define the radius of gyration, which is represented by symbol K, of a rigged rotating body as the distance from the axis of rotation to the point where the moment of inertia of the body remain unchanged if the mass of the body is assumed to be concentrated at the point. This is the definition of the moment of the radius of gyration. But don't claim, my dear student, you have to understand that when we talk about the radius of gyration, this is the distance from the axis of rotation. The distance from this axis of rotation to the point where the mass is assumed to be concentrated and the moment of inertia remain unchanged. Hiyo ndo definition ya ile radius of gyrations. So as we see here that this is obtained by taking K is equal to radical of I divided by M. So How this formula appear? Let us recall from the moment of inertia as we know.